So what we have as challenges in Web3 today, and we kind of identified the main ones. So we are kind of rollup oriented, as you can see. The future is all in rollups. So rollups are not easy to scale at the moment. User experience is pretty bad at this point, and they need some interop, and unification is pretty much non-existent at this point of time. So what the big picture is, the Ethereum-based rollups, they are the center of the whole stage here. And the growth of rollups places a huge demand on Ethereum, or any chain that is. So dank sharding is who knows when. So DA has to appear at some point of time, so we are using that opportunity right now. So there are few of the actual existing DAs at the moment. We are one of them. And hundreds of general purpose apps and specific rollups are appearing, as we say, and as we speak right now. And as we mentioned, the fragmentation is growing. So to address these problems, rollups, as we said, should be interoperable in a trustless environment as much as it can be done. So this is where we appear as Avail. We kind of hope to unify all the rollups across the Web3 space. But, however, coordination is really a problem here. And we could pretty much stop with what we have built so far. And that thing is a promise in our branding, something that is available. But we decided to move forward and create 2 more systems for you guys. So this is our picture of the future of rollups. So obviously we are providing the data availability layer, but there are some things called Nexus and the other thing called Fusion, and which we're gonna touch upon these quickly. So just a quick intro. This is what we have built so far, and this is data availability in its lightest technical sense that we can present this in a short time. So for data availability to exist, we need some proof-based system, and we opted for the trust minimized approach. So to scale rollups, we are building a blob space, and which scales the whole availability through the light clients with our sampling schema that we have employed. And this is pretty much the KZG polynomial commitment that we are using for Avail. These slides are too much technical, so we're gonna fly by. But the most important key aspects of this are we are modular, and we hope to stay, and we provide block space in a modular environment. We have a robust validation system, and each rollup that is built on top of DA, our DA, should be empowered to define, and we're not gonna interpret the meaning of your data. We're just gonna put the data as it is on our chain. So the main leverage of our DA system are the light clients. And as I mentioned, we are heavily leveraging the KZG polynomial commitments and our own data sampling. So we allow verification and intrinsic security with our own network. So again, not going into details here, the main aspects of our architecture here, we provide a block space, we do all the sequencing, all the publication of the data on the blockchain, we group the data, we order the data, and we assign application ID to all the transactions being pushed to the block. We run validators, and we have no restriction on the data format itself. As I said, we don't care what it is, we don't interpret the data, we just use bytes and put it on blocks. In effect, what this has enabled us is to have some confidence, which is provided through the light clients on a higher level without regards to whatever your data is. We call them advanced verification techniques, but they are just verification through the leveraging of the KZG polynomial commitments. And all the data selectively could be downloaded if you provide your app ID attached to the data. So in any time, you can always rewind back and get your own data. Of course, our Light clients are built to be cross-platform. Light is possible in terms of resources, memory, and one day we hope to provide those on your cell phones, on your browsers, for the full decentralized peer-to-peer experience. So, as we said, this is a peer-to-peer network. It is an overlay of the existing network on top of the full nodes. Sampling is also done through the peer-to-peer. This is the main aspect of our client. All the data is being pushed to the DHT tables, essentially inherited from the peer-to-peer system itself. And some statistical point of view is that with hundreds, we consider that a small number of nodes, entire block space could be easily verified with just 200 or 400 nodes. So, as I said, we could stop and give you guys, okay, you have the DL layer, you have your own Light clients, figure it out, guys, screw you guys, we're going home. But we decided to go to the next level and present something we call Nexus. Now this part is where we kind of stopped with the DL layer, and this would be the situation if we said, okay, screw you guys, do your own work here. But we obviously don't want that. This is bad UX right there. This is number of chains interrupt through the bridges, and you know the deal. Hopefully, we want to achieve something like this. So this should be Nexus middleware on top of our system, of our network. So unifying system of sorts. So this Nexus thing will act as a verification hub for all the rollups that are going to come to us, and using the DA stuff that we mentioned before. Now, the key features of the Nexus is we don't specifically need to know the state. We don't need to know the state mutations. We just need to verify that the transactions are computed correctly, and only one single proof verified is enough for the execution to be the relevant execution at the moment. So this is some high technical overlay of the Nexus currently. So as we said, is permissionless verification hub. It should provide a single proof from all the rollups. Essentially, it's a proof aggregation. Providing the Nexus uses that single proof, that is a result of the better UX in the whole ecosystem. And what Avail also offers is the sequencer selection. So all the transactions being sequenced and the occlusion, we all coordinate that through the Nexus. And that is available to you guys. So we cannot go without mentioning the friends from RISC-0. All of this wouldn't be possible without them, and their beautiful tooling that they're building at the moment. So we are heavily leveraging the RISC-0 to be able to create such a system. And we back up RISC-0 with our own DA. But in the essence, RISC-0 helps us improve in execution and the states that are stored on the AvailDA. This brings up to the major point. Any verifiable compute can be turned into a rollup thanks to our friends from the RISC-0. Now, Telos, obviously, this interaction is just also possible thanks to the RISC-0 guys and the Nexus thing that we'll adopt over time. Now, different types of adapters can be used for this thing, for presenting the rollups, different rollups with RISC-0. And you guys heard it multiple times during these few days. A beautiful thing developed with Telos guys is the SnapTor, scalable, robust protocol for decentralized proof aggregation. And we consider the SnarkTor to be the one of the main application on the rollups, and essentially a rollup provider for us, which we greatly need at this point. And the last thing that the Avail is going to provide is something called the Fusion. And essentially a Fusion is a layer needed for the unification to be secure, so to say. It is a coordination layer for the Web3, a shared security coordination layer, where we offer the crypto-economic security, a fusion of sort of securities that grows and goes through us. So yeah, this is the short version of it. Hopefully I was brief and not bored you with the introduction. And if you guys have any questions, you'll have to grab me a few beers. So yeah, find me over there at the bar.